Happy Training Tuesday, everyone. Heidi Reese here from Dayton Superior. We're ready to dive into some pre-stress applications. But really quick, for those of you who may not know me yet, I am the Training Programs Manager at Dayton Superior, and I'm hanging out here with Mr. Chuck Hoke, who is our National Training Manager.
Hi, Heidi.
Yeah, okay. Hi, Chuck. Remember that everyone is muted who has joined, but please use the Zoom's question and answer or chat functionality or both to chat with me throughout the presentation. And definitely at the end, we're going to have a mini question and answer session. So make sure to get your questions ready so you can ask them during that time. So like normal, the training that we will present, any products that are going to be presented in it, please refer to daytonsuperior.com and check out the technical data sheets, application sheets, and whatnot. It's very important to do that before using any of our products. Okay, so Chuck and I get asked about old Training Tuesdays that we've done in the past and where you can find them. Since we record each of these, it's easy to get to the ones you want. All you have to do is go to daytonsuperior.com and search for what? What do you search for, Chuck?
Training Tuesday.
That's right, Training Tuesday. So here's kind of like a look and feel of what's going on. You search for Training Tuesday, you get these three links. The first one there is the latest and greatest of the four typically that we've done, or you can register for the last turn or the coming up one. If you want buy a product, then you've got those boxes there, you've got a little description and your resources. But let's say we want to check out, I don't know, bar supports here. Then you've got all of the rebar supports on that page. And if you scroll all the way to the bottom, I'm not going to here, you can get to other ones similar to that. So that's exciting. I just wanted to show you how to do that since we've had a lot of questions. And if you want to rewatch any of them or pass the link on to someone, please feel free to do that. They all point to the Dayton Superior's YouTube channel. All right, Dayton Superior, who the heck are we? We are the leading provider for the solutions, whether it be for products such as accessories you're seeing going on the screen here, chemicals, and of course, forming. We also provide you with the support such as customer service, 24-hour checking on your account through our systems, your sales team, of course, and the technical service representatives. We provide you with the largest engineering group in the industry so that you can utilize that as well. We're going to be talking about pre-stress, precast type applications. You can utilize them and get out on datesuperior.com to find it. And then, of course, training. Training Tuesdays are meant to be quick, to get you excited about a topic. And if you need more, obviously get in touch with Chuck and myself, and you can do so through training at daytonsuperior.com. And I'll have that up again later on in the QR code for you. But just send us a quick email and we can have some chats with you on what you might need, whether it's ones we've already prepared or a custom solution for your company. All right, let's get to the good stuff, shall we? We're going to do an overview of pre-stress and accessories. And with us today is our presenter, Mr. Taylor Blankenship, who is one of our seasoned technical sales representative within the precast segment here at Dayton Superior. He's boasting over 10 years of industry experience and is a graduate of the Ohio University. I have to make sure I get that "the" in there, right? That's important here in Ohio University. In addition, Taylor is a recognized member of the Precast Prestress Concrete Institute and contributes to various professional organizations such as the Minnesota chapter of the International Concrete Repair Institute, the American Concrete Institute, the National Concrete Association, and the CRSI. One day, Taylor, I'm going to put something in there that's totally random and see if you notice. So he's committed. He's going to talk to us today about some pre-stress accessories. So Taylor, please go ahead and take it away.
Thank you, Heidi. Thank you, Chuck, for putting this together. Thank you, everyone, for joining. Always happy to talk precast. So I appreciate the opportunity. So as Heidi mentioned, today we're going to be highlighting some of our pre-stress concrete accessories. If you're familiar with precast concrete, or if maybe you saw our prior training Tuesdays on precast, pre-stress is a subset of precast concrete. Precast concrete itself is when a concrete element is poured and cured in a controlled environment, typically a precast plant. then it's transported to the job site. So pre-stressed concrete being a subset of that is where high strength cable is tensioned within the concrete. Many of you probably already know that concrete is very strong in compression, but it's very weak in tension by comparison. The tension cable is going to help add a compressive force to that concrete that is then going to help it overcome that weakness in tension. So that's kind of what pre-stress is doing. This is going to increase your strength, reduce cracking. It's going to allow for designs that are going to provide longer spans, thinner sections, can be more aesthetically pleasing. And you're typically going to see pre-stressing in wall panels and beam production. So now that you kind of know a little bit about how this fits in, what pre-stress is, we can take a look at some of our options for that industry. So knowing that pre-stress is a type of precast, many of the same standards and governing bodies, like the American National Standards Institute, American Concrete Institute, OSHA, are still going to apply. When it comes to pre-stressed concrete in particular, there's also the Precast Pre-Stressed Concrete Institute, or PCI, alongside the American Association of State Highway and Transportation Officials, AASHTO for short, that are both highly involved in the pre-stress industry and the design standards that go along with it. We're listing here some of our relevant safety factors, always important to go over. There's a 4-to-1 factor of safety for lifting anchors that are used more than once. That's going to be common in precast and pre-stress, like we're talking about today. There's a 2-to-1 safety factor for lifting anchors that are used only once. You're going to see this typically in tilt-up construction. A 3-to-1 safety factor for permanent fasteners. Think threaded inserts that are going to be connecting your HVAC electrical equipment, as well as a 1.5-to-1 for temporary bracing. And again, importantly, a 5-to-1 for safe working load in regards to lifting hardware. So everything you're attaching to your lifting inserts is going to be at a 5-to-1 safety factor. So as we're getting into some of the accessories here, precast, pre-stressed concrete, inserts are going to be an important part of that. Selecting the proper insert for lifting and handling is a really important step when you're designing. Just because in precast, you know you're handling it in a plant, you're going to be transporting it, and then you're going to be placing it on site. So there's a lot of times you're going to be interacting with those lifting and handling inserts. So here we have a list of just some of the factors that are going to need to be considered when you're determining, what might be the best insert that suits my application. Where do I start? So we could start with the weight of the concrete element. That's pretty straightforward, but you do need to consider too the adhesion to the form surface in your precast plant. If you have something that's more porous, like a plywood that you're using as a form face, that adhesion force is going to be a little bit stronger than, say, a smooth steel form that's super common in the industry. You're also going to have to consider your concrete PSI at time of your first lift. You may be designing a concrete element with a design strength of 5,000 PSI at 28 days, but rarely are you going to have that high strength early on in your precast facility. So where you're designing for 5,000, you might be at 2,500, the day after you pour your piece and are looking to handle it. So that's an important consideration to consider as well. You also need to look at the insert location. Are we lifting on, the edge of a panel, tilting it up for erection? Are we lifting close to an edge? Where exactly are you going to have this insert? That's going to affect your capabilities in terms of capacity. Rigging and direction of pull are also very important. 90-degree tension is always great. That's going to be the ideal for maximizing your insert pull-out strength. However, you're likely going to see a sling angle that's going to reduce on that 90 degrees. As you make that angle harsher, you're going to increase that tension load on both your sling and the inserts themselves. How many times are you going to attach to these inserts? How many times are you going to use them? For a precast product, you might be lifting it out of your form into storage. You're then going to put it onto your transportation vehicle, lift it off at the site, and then final placement. That's going to be affected by that safety factor we talked about on a prior slide at 4-to-1 to cover all that handling. You're also going to have taller panels a lot of the times in pre-stressed concrete. It's one of the benefits of it. So where are you going to place those inserts that are going to help reduce some of that flexural stress as you're lifting a taller and taller panel to avoid cracking? No one wants to see a nice big crack on the front face of your architectural wall panel. Also, another thing to consider is dynamic loading. If you're transporting these in your yard or at the job site that's going to have, bumpy ground, jostling the piece itself, that's also going to increase some of the loading you're going to see on your inserts. So these are all just good things to keep in mind as you're looking at the insert that's going to work best for your particular application. So now we can get into some of our lifting and handling systems. We'll give you kind of a broad view where you might see these in pre-stressed concrete. And we're going to start here with our Swift Lift system. This is a pretty simple system. It's got a ring clutch and a dog bone style anchor. We also offer an eye anchor. Uh, this system is economical. It can handle heavy loads, and the round head on the anchor itself allows you to rotate a piece while you're engaged lifting it with your rigging. So that can be a huge benefit. These are a good choice for columns or beams that you might need to rotate when on the job site. And you'll often see these anchors in pre-stressed wall panel production to backstrip that panel out of the form and transport it for storage at your plant. This is often going to be used in conjunction for backstripping. It'll be used in conjunction with an erection anchor, maybe on the edge of the panel, that's going to be engaged once it's shipped to the site for the final erection of the piece. You can see here, as we mentioned, all of our anchors in a precast tents are going to be 4-to-1 safety factor. The lifting clutch itself is going to be a 5-to-1. That just ensures that that lifting clutch is never going to be the weak point in your chain. So from insert to clutch to rigging, we don't want that clutch to be the limiting factor, the weak point. So here you can see our P52 Swift Lift anchor next to its corresponding attachment hardware and recess. We break this system down by tonnages, and as you can see on the chart on the right, we offer a 1-ton, 2-ton, 4-ton, 8-ton, and 20-ton version. This tonnage is going to correspond to the particular head dimension of the anchor, as well as the anchor thickness, and that's going to correspond to the correct recess, attachment hardware, etc. Also within those tonnages, as you can see on the chart, we offer differing lengths of inserts, and that's going to allow for flexibility in selecting an insert for your concrete dimensions and load and requirements you might have on your job. Moving into the fleet lift system, this is going to be something you're going to see a lot in the architectural precast panel environment. As I mentioned with the Swift lift, a lot of times in conjunction with those. This is a pre-engineered system. What we mean by that is there's a wide variety of form factors that are going to help you tackle various lifting applications. It's a quick connect disconnect system similar to Swift lift that's very easy to install. And it's similar to the Swift lift system in that we offer it in a wide range of tonnages that again are going to correspond to the associated lifting hardware recesses, etc. So here we can see the different form factors. You can see that they're kind of purpose built for a particular job in the fleet lift system. And on the left here, we have our stamped and welded anchors. These are the original designs of these anchors from the past. They were very economical, but they do have a few drawbacks. The stamped steel is more prone to corrosion. It can experience embrittlement when you're at low temperatures, and it relies on the welds, that welded interface to connect a shear plate or a pin to the anchor itself. On the right, you can see similar kind of updated versions of those anchors that are in a forged design. Now, the forged versions are going to improve on some of those weaknesses in the way that they are more naturally resistant to corrosion and embrittlement at low temperatures. The fact that the shear plates are going to be integral, it being a forged anchor, there's no weld that might be a weak point. And as a result, they're often stronger than their stamped counterparts. As these have become more common in the industry, we are seeing, where there used to be a larger price difference between the two, forged becoming more of a standard is going to narrow that gap quite a bit. So it's a great option moving forward. And you can kind of see here in the top left, we have a P92P with a shear plate, an erection anchor, and its version, the P92 FEW in the top left of the forged section there. So similar designs perform the same function, just a little bit different materials. It's going to allow you to overcome some of those weaknesses. So for the fleet lift system, our recesses are available in a reusable system. So we have the blue urethane recess there, as well as a steel option. Can be used multiple times to cut on costs. And we also offer a single-use plastic version for one-off jobs, or if it's just easier in your plant to maybe utilize a single-use product. Down in the bottom right here, you can see a typical application in an architectural wall panel where you have your side form there. An erection anchor is placed in the recess and attached to that sidewall form. Once you remove the formwork, that recess will be there to then connect to your lifting insert, lift it out onto the site, and then you can easily patch with a cementitious patching material once in place. For our ring clutches, we do offer two different varieties. We have a cable bail and a standard bail option. The cable bail offers a bit of flexibility when you're looking at, direction of lift or some slight rotation. I would still say that the standard bail is more common. It's a little more rigid in a straight lift, which is ideally how you're using these inserts. So there's options there, although the standard bail is a little bit more common. Our final system here is a utility anchor system. You can see here that it is compatible with a hook or a shackle. It doesn't have a proprietary lifting clutch. So it gives you a little bit of flexibility there. You're not having to loan out any equipment to an erector team or a GC on site. With those clutches being as expensive as they are, it can be a benefit there to not have them growing legs and walking off on you. This isn't as common in pre-stress applications, but you may see it in some pre-stressed heavy civil jobs that utilize larger pieces of concrete. And they have great shear and tension loading capabilities. Similar to the Swift Lift and Fleet Lift, we do offer a wide range here, although it's kind of the same form factor across the board. You can go all the way from a 4-inch slab or panel up to a 12-inch and beyond with our P75H. That's getting 24,000 pounds in both tension and shear. So a lot of variety there in what you can do from a lifting perspective. Here we have our newly added P77H. This is a double T anchor that we have just released here recently. Normally, you're going to see some recycled strand be used to lifting your double Ts. Double Ts are a great product to have alongside your architectural panels and your bridge beams, just because you already have the facility to do that pre-stressing. This is an engineered anchor that's going to allow you to get, the same capacity every time you use it. There's flexibility, as you can see in the bottom here, with different strand patterns. You can either have it, go between the strands parallel. You can have it straddle your strands, or you could angle it and have it touch up against your strands. So long as you get the minimum concrete cover required, 3/4 inches, you're going to get that same capacity every time. Now we're going to move into our hold down products that are strictly pre-stress item. You can see here that we have our hold down engaging 4 strands in a bridge beam before this concrete is poured. This is alongside the parallel strands at the bottom of the beam that you can see. Now, when a force is applied to this hold down on the pre-stressing strand, it's going to give you an angle, allow you to drape the strands within the beam, the concrete itself. And that allows engineers to manipulate the distribution of stresses within that beam. It's going to allow you to avoid end stresses, reduce cracking, providing a better bridge beam product at the end of the day. So here's a diagram of a simple bridge beam setup. We've got 2 beams being poured here with holdups in between on a long bed. And this is just kind of showing you that horizontal load and that load on the strand itself, represented by capital H. And then we have a hold up and hold down force that's going to be present on these hold downs as you go through the length of the beam. When placed properly, the strength on the hold up and hold down force should be equal. So we're going to do a bit of an example here to show how you might calculate the forces you're going to see on your hold downs when placed properly. In this example, we have our tension force on the cable represented by capital H. In this case, it's 28,900 pounds. Our V dimension is 3 feet, and that is going to represent the strand deflection. And our distance between hold ups and hold downs, represented by lowercase h, in this case is 30 feet. The total pull-up force on the hold down units is going to be the tension force multiplied by the strand deflection V over the distance h. So that is going to give us 2890 pounds per strand. So in this example, we have 6 strands here. So we're going to multiply that strand force by 6, and this is going to give us a total hold down force of 17,340 pounds. We also add an additional 5% for friction on swivel units. Multiplying that by 1.05 is going to give us the total force of 18,207 pounds. In this example, a proper hold down would need to exceed both the per strand load and the total load per hold down. Here's an exploded view of a typical hold down showing you some of the components that go into this. Your strand is going to be resting on rollers, and you might have some you're going to have a side frame. Some designs have a restrainer on the exterior to hold your strands in place. There's a lot of different components and configurations, mixing and matching these components to get what you need. So the strand patterns and configurations are going to vary between the hold down types. We'll just go through a few here. As you can see, there's a lot of different things that you can do based on what you're needing to achieve in your beam. Here you can see a common hold down breakdown sheet. This is going to provide you with coil rod sizing, which you're going to use to connect to your swivel lug and connect to your formwork. It has a max safe working load per strand, as well as a max safe working load per unit. Those are the two variables that we calculated in our example, which is going to tell you, hey, here's the range of hold downs that, based on my math, is going to kind of narrow my list down and decide which hold downs should I be looking at for this particular project. This can all seem a little bit tricky. It was for me for quite a while. We do offer a hold down order form that allows you to ensure that all your information is there, it's clear, and it's going to make sure that there's no issues in ordering these up. Also, feel free to reach out to myself or my counterparts. We're happy to help with that. You can also use hold downs as a hold up, as we did in our example, in between forms or at the end of your form. When you're using a hold down as a hold up, it's important that they be used only one time, just due to the force that's being applied to these. Reuse can result in that material fatigue and wear on the parts that could lead to a failure. That's not good. When strand restraining devices are used as hold ups, it's critical that before there's any load applied, that someone who is an expert is able to verify the loading and ensure that it's safe to move forward. Another consideration to make with hold ups is that you do not want them acting on two loads. So at a hold up point in between the beams, let's say you're pouring the two beams like we did in our example, you would generally want to have two hold downs, two changes of direction there, just to prevent that hold up unit from being double loaded. Each of these hold downs is going to have a 1.5 to 1 safety factor. So if you don't take this into consideration, there will be an issue that is a big problem from a safety perspective. So be sure to utilize hold ups 18 inches apart, 2 each between the beams. So that covers hold ups and hold downs. We'll now move into our H4 pre-stress debonding sleeve. This is a new product that we're just now releasing. Basically, what a debonding sleeve is going to provide is a barrier between the pre-stress cable and your surrounding concrete. When you manipulate where that cable is going to engage with your concrete beam, that's going to allow you to manipulate those stresses within the beam itself, similar to using drape strand with a hold down. So by utilizing this sleeve is going to prevent bonding on the portion that's covered by this sleeve, and it's going to allow the concrete to engage where that sleeve ends. So very similarly to a hold down, that's going to allow an engineer in their design to manipulate how those stresses affect the beam itself. You're also going to see debonding sleeve like this in architectural wall panels using pre-stress cable. This sleeve is compatible with common strand sizes, 0.5 and 0.6 are what you see commonly in the industry. It's a split sheath design, so it's going to have a slit down one side. You kind of open that up, put the strand inside the sleeve. It has fantastic memory and is flexible, so it's super easy to put onto your strand. And with that memory, it's going to be able to then collapse back down and hold a tight hold on that pre-stressed cable. It's made of one piece, so it's super simple. You're not having to clip two pieces together. It's available in 8 foot lengths, which allows us to ship both LTL on standard carriers as well as on UPS or FedEx. And we sell it 100 pieces per box, 800 feet per that bundle. It's brand new, so if you're interested in getting a sample or if you have any questions on that, feel free to reach out to myself or anyone else on the precast team or at Dayton. We're always happy to help.
Awesome. Thank you so much, Taylor. So I'm going to take it from here for the resources, but I want you guys, if you have any questions, please go ahead and put them into the Zoom chat or Q&A portion, and we'll get those answered. Make them tough. We got to stump Chuck and Taylor here. So resources, DaytonSuperior.com. You heard us reference that in the beginning. We have all product pages, technical data sheets, engineering handbooks. You could read the rest here. Anything that you might want, just do a search for. So if you are wanting hold downs, just search for that, and those information, pertinent information will come up for you. Pre-stress and precast handbooks are available, as well as any contact information. You can see Chuck and mine's information on there, or you can, like I said, send an email to training@DaytonSuperior.com. In addition, if you want to know your sales, your customer service, or your counterpart, if you're in the West, to Mr. Taylor here, that information will be on that click or call when you need answers on the bottom right screen. You can go there on DaytonSuperior.com and click about us and contact, and you could find a map, find your state, and simply tells you everybody that you want to talk to. So in addition, I don't see any questions. I guess he did such a good job. In addition, if you need more training, please feel free to either scan this and get us some information and we can chat with you. You can request a training class. We offer lunch and learns, custom, like I said before. We have AIA and engineering classes, and we can do that in person or virtual. And a lot of times we have corporate-led classes as well if we have large enough to get everyone here in Dayton. It's fun. You can, we already talked about search for Training Tuesday, like we showed you in the very beginning. So with that, one more chance for questions. And then it's off for the next week. Go ahead and get out there and register. I'll have the website updated shortly. We are doing intro to epoxies next week, so that should be excited. Okay. Looks like there's no question. Everybody have a fantastic rest of your Tuesday. Taylor, thank you so much for joining us and being so articulate, and I learned a lot. Appreciate it.
Thank you.
Thank you.
Thanks, Taylor.
Bye now.